Hello, my dear overseas students. Well, I've got a very interesting assignment for you. It has been given from one of Uzbekistan students. Well, he has asked for help, and I believe that you will find this problem quite interesting. Well, it's not a high university level. However, it is interesting. I hope that you will share my opinion about the type of the problem. I'm sorry for my French pronunciation. I'm ill and I have a fever plus 38.1. I'm sorry. Okay, I will try to make this assignment interesting for you. Okay, so here it is. Yeah, yeah, it's written in Russian, but I will translate it to you. Given a gaseous mixture of ammonia and hydrogen sulfate, with a total amount of 0.3 moles is burned in the excess of oxygen. The total amount of the atoms of the reaction's products stands at 1.75 moles. Calculate the initial mass of the mixture. So we've got two gaseous components of the mixture, ammonia and hydrogen sulfate. Well, we know its amount, which stands at 0.3 moles. Okay, and also we know that the amount of the atoms of the products of the two reactions stands at 1.75 moles, and we're supposed to identify the mass of the initial gaseous state. Well, the problem can be solved with the help of an equation. Yeah, usually in such circumstances, the first step we are supposed to make is assuming which of the two reagents should be taken as x. Actually, it doesn't matter which. Therefore, we can arbitrarily assume that the amount of ammonia equals x moles. Let's write it down. So the the amount of ammonia equals x moles. Okay, and that means that we know in algebraic points of view that the amount of the other component, which is which is H2S equals 0.3 minus x moles. Okay, so far so good. Then, what can we do? We can write the scheme of the first reaction. So 2NH3 plus 1 and half O2 yields molecular nitrogen, and 2 plus 3 moles of water vapor. Okay, that's the first reaction. Okay. Now, from this reaction scheme, it is clear that the amount of molecular nitrogen, this one, molecular nitrogen, is half of that of the initial ammonia. We know that the initial ammonia amount stands at x moles, right? We've got the coefficient 2 here and coefficient 1 here, and that makes us believe that the amount of the molecular gas N2 equals 0.5 N of NH3, right? So nitrogen, molecular nitrogen, okay? And we know that it means 0.5x moles. However, so we're supposed to pay more attention not to the molecular part of the matter, but to the atomic part of the matter, because they tell us that the total amount of the atoms is 1.75. For that reason, we should understand that one molecule of N2 contains two atoms of N. For that reason, we can write that the amount of N atoms equals twice that of the molecules. And that means we should multiply 2 to 0.5x. That gives x moles. This is the amount of N atoms. Okay, then, so we are through with this part, and now we can proceed to this one. we see that the coefficient here is 2, and here the coefficient equals 3. For that reason, we can write that n of H2O equals 3 over 2 n of NH3. I guess it's clear, and that means 3x over 2 moles, okay? But we also see that one molecule of water contains 3 atoms, 2 hydrogen atoms and 1 oxygen atom. For that reason, the amount of the atoms of H and O atoms equals 3 times the amount of water molecules. And that means that we're supposed to multiply 3x over 2 to 3, and we will get 4.5x moles. Okay, yeah. And totally, we can see that in the first reaction, the total amount of sorry, of atoms accounts for x plus 4.5x, and that gives 5.5x moles. But this is the amount of atoms, and that is related to the first reaction. But we've got the other component, and it's also oxidized, right? And here is the reaction H2S plus 3 and 3 over 2 O2. That gives SO2 plus H2O. Okay, and we're going to apply the same logic. Now, the amount of SO2 1, right? That means that the amount of SO2 is the same as the amount of H2S. And that means that it's 0.3 minus x moles, right? But we also can see that there are 3 atoms in one molecule of SO2. For that reason, we should multiply the amount of atoms in SO2, which is multiplied to 3. And by doing this, we will get the amount of the atoms, okay? And if we compare the coefficients before H2S and H2O, we will get the same picture, and that means that the total amount of H and O atoms is the same, okay? And that means that in the second reaction, the total amount of atoms is 0.9 minus 3x plus 0.9 minus 3x, okay? And that gives 1.8 minus 6x moles, right? What's the total amount of the numbers of the reagents of the 2 reactions? So we should add this one with this one, right? So 5.5x plus 1.8 minus 6x, right? And that gives 1.8 minus 0.5x moles. And if we look up at the assignment, at the problem itself, it says that the total amount of the atoms of the 2 reactions is equal to 1.75 moles, right? And so if we get to the root of the problem of the equation, so we'll get that so x is 0.5 moles, 0.5 moles, and that also means that we know how much was of the ammonia in the mixture. It's 0.5 moles. And also we know how much of the other component was in the mixture. It's 0.3 minus 0.1, that means 0.2 moles. Now we can easily calculate the amount of the gaseous mass. It is that, so the mass of this gaseous mixture equals the molecular mass, the molecular weight of each of the component times its amount of the substance, and we will get the following: zero point 0.5 times 17 plus zero point 0.2 times 34, and finally we'll get 8.5 grams. This is the answer to the question. Thank you very much for your attention. So if you've got any problems, feel free to contact me. Bye.